Hello, Year 7. Could you please make sure that you watch this video all the way through to the end, as it's got some important information in it. As you guys have been doing your homework electronically or over the computers, we've decided we're going to change the number system that we use for our homework for the next topic, okay? So we're going to stop using the base 10 number system, and the reason that it's called the base 10 number system is that it's got 10 digits. You can see it there: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 is just a combination of the 1 and the 0. So counting the 0, we've got 10 different digits. What we're going to move to instead is using the binary number system, okay? Because that's actually what computers use. They just have a bunch of switches that are on and off, which they use to count. The same way I guess we use our 10 fingers to count. So let's just take a look. 0 is the same as 0. 1 is the same as 1, but because computers only have an on switch or an off switch, we've only got a 0 and a 1 to work with. So 2, I can't use a new symbol for 2, so I've got to then move up to the next column. So instead of having a 1's column and a 10's column, I've got a 1's column and a 2's column. So this is a 2 and a 0 is 2. This is 2 here because it's a 1 in the 2's column, and this is a 1 here because it's a 1 in the 1's column. 2 and 1 is 3. Okay, for 4 I've got 0 in the 1's column, 0 in the 2's column, but now because I can't actually use a different digit in this one, I've got to make a new column for 4's. So this is 4, 1 4, 0 2's and 0 1's. 5 is 1 4, 0 2's and 1 1. 4 and 1 is 5. 6 is 4 and 2 is 6. 7 is 4 and 2 and 1 together is 7. But see how I've now filled this one up with 1's? I can't do anything else to make the numbers go higher, so I add a new column for the 8's. So my 8 is 1 8, 0 4's, 0 2's and 0 1's, and then I start counting from the end again. So I've got 1 8, no 4's, no 2's, and a 1 is 9, and 1 8, no 4's, a 2 is already up to 10, and then no 1's. So let's now take a look at just how to convert a bigger number, okay? So to convert a bigger number, we want to convert 73 to binary. So I'm going to write up all the powers of 2 here. I don't need to go to 128 because that's too big, and I think, okay, well 73's got one lot of 64 in it. 64 and 32 is a little bit too big, so I'm definitely not going to have any 32's. 64 and 16 is I think 80, so that's a bit too big. 64 and 8 is 72, and now I only need one more, so I can't have a 4, I can't have a 2, but I can have a 1. So 73 is 1, 0, 0, 1, 0, 0, 1. Okay, so let's try another one. This time I've got some binary number and I want to work out what it is in our regular old base 10. So let's take a look. I'm going to first of all just put it into this table here. I've got 1 1, no 2's, 1 4, 1 8, 0 16's and 132, because I'm just matching this number up to this table here. So let's take a look. We've got 32 plus 8 plus 4 plus 1, which equals to 45. Okay, but you're going to have to get used to just doing your summations and your operations just with binary numbers, because all of these numbers 2 3 4 5 6 7 8 9, well, we're still going to use them, but they'll all be 1's and 0's, so we won't be writing these symbols anymore. Okay, so let's now take a look at our regular algebra revision like we do each lesson. So here we go. I've got 5x, and question 1 of course is 5x minus 3x plus, and this is going to be x cubed minus 2x cubed. So let's see if we can work out what this is. I'll just do a little column over here for my answers. Okay, so I've got 5x minus 3x is of course going to be 2x, and I've got here 3x cubed minus 2x cubed, so there's of course x cubed minus 2x cubed is just going to be minus x cubed, so minus x to the power of 3. Okay, next one, it's power. So we've done our powers as part of our index laws, so this is question 2. So I've got 3x to the power of 5 times y cubed all squared. So just remember, we do 3 to the power of 2, so that's just 3 squared, which is of course going to be 9. And then we've got x to the power of 5 squared, and we're going to multiply those indices, so we're going to get x to the power of 10, and there's x to the power of 10, and y, I've got y cubed all squared. Again, we're going to multiply those indices together, so we've got y to the power of 6. So of course we just get here 9x to the power of 10, y to the power of 6. Okay, the last question we've got here, and obviously we've got 6a squared b to the power of 7 over 3ab squared. So what we're going to do is we're going to simplify it. We simplify the numbers first, so 6 over 3 is just going to be 2. Subtract these indices, so a squared minus a is just plain old a. And we do the same for the b. We're dividing, so we're going to subtract the indices. So I've got b to the power of 7 divided by b squared, and subtracting those indices, that's just b to the power of 5. So for not for this topic, but for our future work, and particularly when we start our algebra, we're going to change a little bit how we do it. So we're only going to be using these numbers 0 and 1, okay? So we'll still be calling these numbers, we'll still be calling this number 2, but we won't actually be writing any more of these symbols here, okay? So these symbols here we're going to be getting rid of. So we'll have all of these ones, we won't have any more, and we're just going to have the first 2. So we'll be doing all of our writing and all of our mathematical notation just with 0 and 1, starting from the next topic, okay? Alright guys, thank you very much, and of course our puzzle for the day.